Mm, I wanted to provide some updates on the decorations I have been working on recently, and maybe I also wanted to see if we can import a shader from ShaderToys into our terminal. So first thing, last time we were working on this decoration here for the polar clock. We had added a couple of whiskers here, and also yeah, this red line here was showing us that it was showing us that we are working after 5 p.m. or something like that. So I wanted to show here when it is time for me to stop working and I can do other things. So basically from 9 to 5 it shows bluish and then it shows red. Then this beam of light also interacts with this rendering part here. So this beam of light is taken from Carl Sagan from the Pale Blue Dot. The idea here is that maybe we are like kind of rotating. Yeah, the idea is to give we are kind of rotating and we want to see a beam of light that should be, you know, just something that tells us that we are moving through space. Then we have also added this. This is the state of the moon phase. For this we're using a cargo crate that is called moon phase, and it tells us what is the percentage of the illumination or the fraction. So we build here one static like circle behind it, and then we build an arc with Bezier lines. Actually we build two arcs. One is the first one over here and the other one is this one over here that goes up. So this one it will be moving depending on the day. If you notice, there is also some sort of shadows in the background now. These shadows are moving very faintly, and this is also a shader toy that is called Vortex Street. We're also going to look into it. If you can see here, for example, you can see that there is some sort of arc, and this arc should be moving through time, and right now we can control how fast we can move the shaders. So yeah, we have added this Nannou decoration, and then this is a shader toy. So this is everything here is that you see, for example, these kind of shadows and the beam of light. They are controlled by yeah, they are controlled through the fragment shader. So my setup right now is that I have a terminal running Cargo Run, and then I have the other editor where I am looking into things from here. So the first thing that I had to do to be able to interact a little bit with the shaders from ShaderToys is that I had to add some uniforms. So the first one is the eye time and then the eye resolution. So the eye time should be the time with seconds, the time in seconds, but basically would, in this case, for example, is allowing us to move the shadows or to move the beam of light. And then the eye resolution is also important because we're gonna move, yeah, if we resize the terminal, we also want to tell the rendering process that we're changing the uniforms basically. So to do this, to the hexagon shader program that I had before, which it's not really a hexagon BG anymore. I think I'm going to call it a decoration BG, or decoration background, or decoration hexagon background. I'm not really sure how to call it yet. But I had added the U resolution, the U time. Now, so this is a little bit tricky for me. If I go into the documentation from maybe one of the tutorials for OpenGL and the book of shaders specifically, they talk about creating uniforms in the fragments that are starting with U underscore. If I go to ShaderToys, they start with eye time, eye resolution, eye channel 0, and so on. Yeah, so I am every time I can. I think basically before we had done something that was like we had a process that is called tick, and this tick process is an event that we are receiving over and over from Tokyo. Actually, we're generating from Tokyo, and Tokyo is saying, "Hey, something's happening." So every interval, it sends an event, and then it triggers a redraw. And what I did before is that I think it was every 10th of a second, an event is sent, and then it causes a redraw. Or not really a redraw, but it really says, hey, something may have changed. So for example, these hexagons are static. Only when we resize, we need to compute new vertices. So for example, if I am making the terminal bigger, I may need more hexagons to cover it. But if there is no resize, for example, if every 10 seconds the user is double clicking or just moving around the terminal, it should not go and recreate all these hexagons, right? This is something that would be very expensive for us, so we don't really interact with that. However, this uniform, for example, the one that is moving this light, as you can see, it's very faint. So this is moving, I think at this point it will be like 10 frames per second. Yeah, I'm not sure if it is a tenth of a second. It might be a tenth of a second. But it looks pretty close. Okay, so sorry about that. I'm not really sure. I think I'm testing a new chair and it was cracking now and then, so apologies. Yeah, probably it's the chair. Okay. Okay, so let's continue. I think for this time, what I wanted to do is to look at a shader, because it's getting like this time of the year where there's a little bit of snow, or things are a little bit frozen, and I thought, why don't we add a little bit of an effect like this? So you can see here that this is very, very fast, and it might be simple for us to import it, and also I can kind of tell you how I interact with this, how I get to this magic number sometimes when I need to get things working. So first, let's look at how our terminal is behaving. I'm gonna save a file just to trigger it to reveal the terminal. So somewhere it should be compiling. There we go. Yeah. So you can see right now, yeah, this is the same terminal that I'm using for editing. There's not much different. Yeah, the beam of light is there. And then this background of the vortex street, we may want to disable it temporarily. So what I have been doing so far is that, first of all, I have to make sure that, yeah, when I go into one specific shader from ShaderToys, I try to find if, for example, this one is under Creative Commons, so I don't have problems with this one. Usually they also tell us where, yeah, if they made a change, an adaptation over a previous shader. So let's go and look at our shader right now. So our shader here, let me move this around a little bit. The shader use, let's see, there's some sort of information about the license. I don't see much. Yeah, in this case, I'm not sure if we can use this one, but just for the sake of the experiment, yeah, we're not gonna publish this anyway. I'm not sure if I can open this. free software, free society. Yeah, it seems like it could be. I might shoot them a message or something. Yeah, this makes me think that it could be related to free software, but yeah, without a specific license to computer graphics. Well, let's give it a try anyway. Just for the sake of experimenting. So what I'm gonna do is I'm gonna copy all the code from this. So this is a very simple one. There are no channels. That means that I do not have to load any textures, because otherwise I will have to find a way to load textures and then provide them. There are some textures in the terminal. However, for example, the fonts, I think they are loaded as a texture. Yeah, I don't think I can use them for when we have textures. So in this case, for example, everything here that we see is calculated from from this code. There is no image that we are loading. Also, it'll be fast, and also we want to preserve certain things from the terminal. So not everything that we see here is going to be useful for us. All right, so I copy the code, and now let's go into the editor. So in our editor, I'm gonna paste this below the vortex tree that we saw. All right, so let me just get rid 1 second of this terminal from here. Okay, so the first thing when interacting or trying to have our code works with the ShaderToys is that this main image needs to be called from somewhere, of course, and the main image doesn't really mean much for us. I think every shader in ShaderToys is called it has to have a method called like this. So I'm going to copy the URL of the shader, and then I'm gonna add here from. So this is just for our test. We're not gonna commit this. We're just gonna see if we can make it work with our current terminal, and then maybe we can find later a way to get it working. Maybe there's another version that is using so I need to return a color T. You know what, I think I know what the sounds are in the background. It's the celebrations of the World Cup, probably. Yeah, that's probably it. All right, so instead of main image, I'm going to call this Snowy. I think that is the name that we had before, right? Or the name of the shader in ShaderToys. And then this red color we're gonna have to return. So for now, if I look at the reference of red color, it's only the end. So I'm going to return red color instead of that. And then if I come into the frag chord, we do not have this kind of we do not have this kind of naming. We are going to use whatever is provided for us in the shader. So this is a GL frag chord. Oops, GL frag chord. Okay, so now we can remove this item here, and then I also want to send the current color of the pixel. So for example, if this bluish thing is, so I'm gonna call this base though. For now, I usually call it base in the experiments I have been making. So what we have done then is we have renamed the main image to something that is relevant for us. Then we have said that we are going to send a base color, and this base color for our first test is going to be just the alpha. So basically, we will not see in this separation of hexagons, we will not see any snowflakes. So this is going to be base-.a. And then if we come into our vertex street, we're going to change this for snowy. So let's see what happens if we try this. I'm not sure if we will need, if we're gonna need to import anything or maybe make any transformations. Okay, so what we can see here is that there are some snowflakes, right? They are not moving yet. I think this is because the time that we have on the terminal and the time that we have on the shader is probably 1,000 times of difference, because probably it's not really a seconds as the documentation claims from shaders, but it's probably milliseconds. So yeah, this is the moon that we saw on the shader, and then this is the snow, but it's not moving yet. And of course we lost all the color. What we have, for example, as the shades of the background, the vortex, all these things are lost. So let's try to at least we have the alpha, so we can see that there are some hexagons still. The hexagons data still that is there. So the first thing I want to do is try to see if we can make this move, and then we probably want to get rid of this moon here because we already have a moon, and it would be cool if this moon was here, but I think we have to send additional uniforms and change it a little bit, and I'm not sure if we can do this for the first session. So yeah, let's try then to do the first thing, which is let's try to see if we can make it move. If we come back to the code that we downloaded, there is a reference to speed, and because I know that I think I'm using like every second I am sending this time in milliseconds. Yeah, so if we make the speed 2000, it could do the trick. That could be the first part. Then we can also try to combine the snowy with the vortex with these with the shadows that we have here that are variable, and see how it would look. Okay, so now we can see that the shader is moving, but it's moving very, very fast, right? It's going super fast. So instead of 2000, let's make it 200. And while it compiles, let's go and also play around with our values for the snowy. So I was thinking that we can get this in. Okay, it looks much better. I think when this is good to see that it is moving, but we also want to add at some point. Yeah, we want to add less speed. We want to remove the circle and remove this diagonal here. Yeah, we're probably gonna make it much slower because I don't want to be interacting. Maybe if I am editing something, we will test it later. Maybe it could be a lot. Also because I have been working with this for quite a while, I am used to having all these distractions or whatever you want to call it. So I add one effect through time, and then I get used to it, and then I get another one, and then if somebody comes and sees the terminal for the first time, it's like, wait, there's a lot of moving parts. What's going on here? But it's all because I'm filtering in the end everything, I guess. So. Yeah, I want to have a way in which I can add them, for example, maybe during 1 hour, if it is snowing, I don't know, we may find an API. We can find, for example, the clouds. So if it is very cloudy where I am, I want to show a couple of clouds. I also want to show something like, we spoke about this red line here, which shows the, if it is during work hours or not. And what I was thinking is that we can also include here the time in which there is sunlight. So I can see, for example, how through the days, through the year, there is less and less sun, and this could trigger me to at least say, you know what, it's gonna be sunny only in the next hour. Maybe if I want to go for a walk, this is the time, otherwise the time is lost. And yeah, depending on where you live, we may have something that tells us, depending on where you live, it may not be useful because maybe you live in the equatorial side and then, or the equatorial center, whatever it is called, I have no idea. And then, yeah, it's always sunny during the same hours, or yeah, but also I was thinking that if it is gonna snow, it's not gonna snow, or if it's gonna rain or something like that. And if, depending on where you are, you have a good meteorological system, which I don't know if there is an open API for that, then we could have this. And of course, we also want to add at some point that the moon moves depending on where I am physically located. So if I am in Europe, then I wanted to show that, you know, whatever in the sky, somehow, I'm not sure yet. Yeah, there's many things that we want to add, but let's sorry, let's focus on what we were working before. So one step at a time, what we said is let's try to preserve the color. And what I think is that we are sending the base, and maybe if we multiply everything by the base, so the first thing is R, G, oops, multiply this by G, and then red, green, RGB, yeah, red, blue, green, red, green, blue. What am I talking about? Base dot blue, so RGB, and then if we multiply by everything, this may give us a better effect then, because at least I think we could preserve the initial colors, although this is not always a given, because we are multiplying by something that may alter them a little bit, but at least the interaction between the values. Yeah, so I think it looks like we preserve. Yeah, I think we are preserving now the colors. Yeah, definitely we are preserving. Let's see, let's wait for the ray of light to come by. Yeah, there it is. Yeah, so what we have to remove now is that we still have this second moon, which we already have a moon, so we're gonna have to get rid of it. So somebody in that specific comment, that specific shader, they also ask a similar question. They say, hey, I want the snow without the moon. And then, oops, this person replies that you have to modify sun variable on line 108. So let's give it a try. Basically, I want to get rid of the slope and of the suns. So this is line 108 on the initial color. So let's see, I may be able to just delete a lot of code from here. So let's find where we have suns. Then we can delete this sun. This sun SH we will also remove. I'm gonna remove any reference to suns, and actually to slope as well. So I'm just gonna remove this here, and also the sun SH. Kind of means that N5, N4, N3, N2, N1, and then oops, I think I have to remove this thing too. So kind of we multiply this by 2. Wait, why is he doing this? Yeah, for some reason he's multiplying this thing 2 times. 0.35. Well, not multiplying, but initializing this 2 times. I'm gonna remove that. I don't think that is needed for us. And then in here we also want to remove the slope. So if we remove this slope here, well, this noise is used for the slope only as well. Now let's remove this. Let's remove this. Sun SH we can remove, and we can remove the suns now. So in theory now, regardless of where I am, I shouldn't see this diagonal line, or I shouldn't see the sun. I think for a later version it will be cool to have this shine effect over the current moon. And then we can also try to see how we can get the snowy side here along with the vertex, but it may look too clumsy. Okay, so now it looks very, very dark. I think the hexagons are barely visible. Yeah, the hexagons are barely visible, which may be something that is good. Maybe something that we want. 1 second. I'm getting a little bit of a cough. Yeah, it lost a lot of the definition of the hexagons actually, to the point that, yeah, actually I'm not sure if I like it. Let's see if we can, let's see what we can do about this. What can we do to different? Because basically, let's play around with this number a little bit here. This is the green. Let's see if we add this 1.5 here. So it's a lot about playing around with numbers. Of course, everything's about playing with numbers in this case. But yeah, it's all about adjusting them to play nicely with the terminal without being. Yeah. So in this case, it's way too much. Too much green. Now it gives it like a kind of. Yeah, even yeah, it doesn't have to be precisely bad. How can we modify this a little bit more? Because what this returns, we could also, let's think. Let's try to do something different. And we have the base that are, so let's do base that are minus, and let's take this number and multiply by 0.9. So whatever we had before, we're gonna get, actually we're gonna get basically, yeah, 1/5 of the previous value. We will subtract it from our current values. So we will do the same here. What we're trying basically is that we're gonna get 1/5 of the effect, and we're gonna subtract it from our current colors, and we're gonna claim that maybe that makes sense. Maybe this 0.2 is too much. We may try to do 0.1, and then maybe we lose a lot of the effect, but let's see how far we can get. So we get the current green color, and we subtract this times 0.2. So basically, yeah, 20%. So base.b minus, and then this 0.2, and then we retain the alpha. Yeah, so maybe we can make this a variable that is gonna be called like I don't know, snow override percentage or something like that. Let's see how it looks. Okay, so now we do not see anything. Yeah, actually there is something. So we may want to add it, because I think the more we head towards, yeah, that's true. The more we head towards 1, the closer we are to white. So let's, and because that is the case, should we try? Yeah, let's see. Now we are going to just add these values and see how close we get. Yeah, so now they are a little bit visible, but it still is very, very faint. So let's add 50% of it. It could be like a snow multiplier or something like that. I wonder if the base, we can use it for something here. Maybe the base we can leave for the vortex. Okay, I think it looks much better. But I have a feeling that yeah, I think it looks much better. Let's see how it looks with the vortex also. I also want to reduce the speed. Let's reduce by half. And then we are first going to call vortex strict. And then we are going to call the snowy effect on top of it. I'm not sure which one is better to call. Yeah, let's find out. Okay, so now, yeah, now the particles are moving very, very slowly. I'm going to try to use Tmux on top of it for a second and see how it feels. I think it's fine. Yeah, but not sure if we lost a lot of color. But yeah, I think maybe I'm gonna go over a little overview because I think it's finished much faster than I was expecting. On how, like, what we are really doing here, because there is a process that is already rendering everything that we see here, right? Like all the real use case for a terminal. But we do not want to play with this specific, with this renderer, right? We want to leave the terminal process that is rendering things just, alone. And then these decorations that we are adding are a separate shader. So you can see, for example, that the light, the beam of light that travels, does not interact with these things that I can select, these glyphs, right? Like the real data from the terminal, all these numbers and all these ASCII characters and whatever, they are not touched, like they should be left alone. So sometimes also, this is why I think that some of the things that are here should have a little bit less shine. Because otherwise, if I see an F here, maybe the background breaks the real understanding that this is an F and may look like another number. So maybe actually bad for us. So we can see, for example, here that this between the D and the 2, there is a shade of red, which is the indicator of the hour that we have. So it's not always good, of course, I think, or is never good, I think. Many times you could say that as well. So what is going on here? This HexPG renderer, for lack of a better name, it's doing more than a HexPG now, because, for example, this snowy effect is added on top of this fragment shader, and then there is a vector shader that its only task is to retain the color. It doesn't do anything. So the fragment shader is where we are doing the vortex, and then in our there's a frame buffer object that is not being used. So the main part here is that when we want to interact with this renderer, we have to send vertices that contain this kind of structure, where we have 3 inputs for X, Y, Z, and then 4 inputs for RGBA. So the reality is that the Z parameter is not used yet. I wanted to use at some point, for example, I want to calculate where the International Space Station is, and maybe the center of the terminal is the Earth, and then depending on where I am located, I would see the International Space Station moving. Just like a little thing that now and then appears. So that's why I introduced the Z parameter. And then we have red, green, blue, and the alpha. So basically we have 7 items per vertex, and we have 2 positions in this case, right? The first one is going to be the XYZ. So then we have to advance 7 positions, right? We spoke about 7 here, and then we would get to the second location, which it contains the color data, so RGBA. And again, as we said, we advance in sets of 7. So to be able to send this data to the GPU, this method draw is called. So this method draw is going to receive some sort of OpenGL data, and a GL mode. The GL mode is to say I want to draw triangles, or I want to draw just a line, or I think there is line strips, and there's like 7 things that we can do, line loops and so on. To be honest, I have only had success with using either one of them. I cannot use them in conjunction. So for example, if I use GL lines, I only get the lines of the hexagons and then the lines of the Nannou, because Nannou is also written on top of this renderer. So if I use a GL mode that is not GL triangle, which is the default, then everything, the moon, the polar clock, the hexagons, everything becomes a line. I think it is something like whatever is the last GL mode becomes the global GL mode. I think that is why they have a pipeline idea, but I am not sure really what it means yet. Okay, so I was talking about some uniforms that we have. For example, this line that is moving, this beam of light that is moving, this is a uniform that is like saying, hey, let's move this x parameter to the left. So we decrease, and then we calculate basically just the horizontal. So we are only moving one position, and then it goes like twice the size of the display. We also are sending to the update uniforms the size info, because we want to show these uniforms that we spoke about before, the eye time and the eye resolution. So this is what allows us to be a little bit compatible with what ShaderToys has. And then, yeah, we send these uniforms in the update uniforms. I think there are many more in ShaderToys, but I have not had the need to add them yet. So yeah, we send the OpenGL data that we received in this function. So let's find out who called this function. So yeah, go to references, and then I name this function draw xyz RGBA. So basically this receives the vertices for this kind of triangles with this structure, and then the draw array mode. So this is part of the core Alacritty source renderer mod. However, the reality is that this method didn't exist before, because yeah, it's basically, actually these two methods didn't exist before. They are simply like kind of inline. But I wanted to reuse them. I wanted to prevent copy pasting. So basically, what you see in the real Alacritty code is that it first calls this unsafe here, which I call prepare rec rendering state, because I also want to use it for my other methods. So I didn't want to copy paste these these lines, and then this other activate regular state is also another one that I introduced, which is very simple. It just, it's just a section that I also want to reuse. So you can see here the direct is the real function that is called from the renderer, from the display loop, and then I have a copy of it, which I call xyz RGBA. So to it I can send it. So let's go 1 second to see, this is our render, right? Let's see who calls this function. So this is called inside the draw decorations in the display loop. And if I go to the references, this is done after we display the text, after we draw the screen, all these cells, the grid, the triangle. So this is the real method from Alacritty. So kind of what it goes through is it finds the cells, it finds if the cells are underlined, if they are not, if they are, if there is background or foreground colors. if something that I also needs to render is that if there is an error in the configuration, it wants to show it as soon as possible. So if you write something in the file of the configuration, you have a typo, then it's going to show you a little line here, a red line, which may be an error or a warning. For example, if it is deprecated, it will show you something that is different. So an example of this is that I believe it's around this area where it's going to say that, you know, you have a warning of some sort. Yeah, somewhere around here it is. There it is. So if it is an error from the configuration file, for example, the message buffer contains an error saying, hey, you have a typo in your configuration, then depending on if it is an error or a deprecation, then you would get a different color, and so on. So basically, I have a flag that is called if the decorations are enabled, then I want to draw the decorations. And then this draw decoration, oops, I have a wind effect here that I no longer need. I can remove this now. I'm going to remove this as well from here. Hexagon opacity. And the screen size. Yeah, this is not sure why I have this. I may not be using this at all, I think. Yeah, I'm gonna leave this 1 second here. Just gonna mark this that I should remove this. Yeah, this HexPG shader is becoming like a decoration background shader. It's no longer a hexagon related. Well, yeah, there are some hexagons there, but there is also the polar clock on it, so it doesn't really make sense to keep it. So this is what I was mentioning before, that there is a tick function. Every time we call the draw decoration, we're going to tick. So this means go into each one of the decorations, and then, for example, I want this second counter of the polar clock to be updated, and so on. So everything should be updated. So basically what it does is it calculates the current position, and it says, hey, has this changed from the previous time that I draw this? So we draw a second once a second, or more than once a second actually. We draw a minute once per minute, and so on. Like we only redraw when something actually needs to be redrawn. Okay, so I have different types of decorations. I have decorations that are for type lines. So these are examples for line loops. We have triangles. So these are the hexagons that we see here. These lines here are built using a mode of line. So we are reusing this. Actually, it's called draw array. Actually, in this case, because they may be separated. So there are also points, but I'm not using points right now. I think I want to use it soon. I want to use them soon. But I forget really what it was. There's so many things that we could add. Yeah, but anyway, the one that we are interacting with right now is this draw RGBA. The Nannou decorations, they are, for example, the polar clock and the moon, they are written with Nannou. So let's go into the definition of the decoration triangles. We have a box of a Nannou decoration, and then we have a color, an alpha, and this is gonna be something that we do for I think a general setup. So for example, the moon is going to be using this color, but the alpha is not really an alpha, it's an alpha multiplier. And then we have a radius here of where we want to draw. So this may be reused by other things. So if we go, for example, into the polar clock, we have a unit state. I think we have been through this in another video, where we have the last drawn unit that I was speaking about. Basically, we try to draw these vectors or to calculate them only when this unit changes. So we tick through time and it says, you know, the main hasn't changed, of course, every second. So only when it changes, we update this value and the vex, and we have a needs dirty, which is a way for us to force things to be redrawn. So for example, when I resize, I will need to redraw everything, because as I resize, the center of the screen is going to move, and then so will all these vertices. Maybe there's a better way to do this, but not right now, not yet. So yeah, that is maybe the last trick that we have is this nano decoration. As I was saying before, we have this XYZ RGBA array drawing, and I have from Nannou I calculate or I don't calculate, I get the vertex.x. So basically I send to the draw, I initialize the draw, I call certain draw functions, and then there are some primitives that are going to be generated in a plane from Nannou in its own state, and then I can go through all the draw commands that basically say, you know what, if you're saying draw.ellipse or draw.bezier curve or all these builder of the paths, then it is going to generate in the end a lot of different primitives to fulfill my request. So in this case, for example, it is going to say, you know what, it is going to generate some triangles. I think you can define a draw mode. I think by default it is triangle, so I don't need to specify it. Yeah, so I drain the commands, and then I iterate over each one of the primitives that is generated. And then for each one of these primitives, I can get their X, Y, RGBA. And then if I get all these values, I can create these this X, Y, Z, RGBA, these 7 values per vertex thingy that we are sending to the GPU. So basically I can return this, and then I can iterate over this and treat this as just another part of the hexagon shader. Yeah, so maybe the last thing that we could do just for fun is that there is also this matrix. This doesn't work well yet, but there is a matrix range shader, and just to make things really ugly in the terminal. So basically, when I was following this Nannou, the steps that I followed was also the same thing. I went to the shader, I find maybe what are some values that I could interact with, and then yeah, just try to make it work with the terminal without being extremely annoying. But this one for matrix, it looks extremely annoying, sadly. It's just I just was fooling around with different shaders from ShaderToys. So this is how it looks like. What I think I wanted to do in the future was to have the letters of the terminal that maybe I press a key combination, and then it things will look kind of like this, just for wasting CPU, wasting time, annoying people in calls, many other valid reasons, of course. Yeah, so let's undo this and let's get back one last time to how the terminal looks. I'm gonna try to open this in another window because right now it is rendering on top of my previous terminal, so it doesn't look as annoying. So this is going back to the snowy effect, and we can see that, yeah, I think it looks pretty nice. I think I can code here without being too annoyed. And for example, if I am in this terminal here, I think it looks usable. I don't find it extremely annoying yet. Tomorrow maybe a different idea when I am working on it. But I think I like it. I just wish this was something that I could really use, because the license may not allow me to use it. So I'm gonna send them a message on ShaderToys. I've seen this a few times when people ask, hey, is this something that I can use, maybe Creative Commons or GPL or something. I think I really like the way that it looks like this. Okay, so I think that's gonna be the end of it for today. I don't think anybody watches this yet, except for me, of course, and maybe my friends. But if you find something on ShaderToys that you like, if you find something that looks interesting in ShaderToys, try to make it work, and then maybe you can share with me how you got it working. So I don't know. I'm not really sure how to use this site properly either. But what I did is search for snow, and I saw this effect here. I think this one looks amazing, but this is too advanced for me. I think many of them are, maybe we can do another experiment in the next one, where we find one that says explicitly, this is a. Also be careful, because many of these sites have a warning. And I think this is happening to me right now, that maybe my computer, even though it has a decent GPU, maybe with all the load of the terminal, it is having trouble loading things. Yeah, I think it has killed my browser session, sadly. Alright guys, so that's it. Thanks so much for tuning in, and don't forget to share in the comments if you like, or if you can share some code in my repo, that would be even better. Where you can say, hey, you know what, I tried this specific shader and it looks super cool, and this is the values that I use to be able to make it work properly. So this is my Git repo. Again, this is a modification of Alacritty. It's only Alacritty plus annoyances, so do not expect that I'm following something to be, what is the word I'm looking for? I'm looking for speed or anything like that. I'm just looking for fun. That's generative art in general, I guess. Okay, thanks so much. See you.